Welcome to Let's Get to the Marks. I'm going through the Magdalen College School Chemistry 16 plus entrance exam, and you're allowed 45 minutes for this. One of the top 10 schools in the United Kingdom, really good school, and let's get into the exam. So, use a black or ballpoint pen, attempt all questions. It's out of 30 marks. Let's go. Question 1. The diagrams show the nuclei of four different atoms, Q, R, S, and T. We've got a little key on the side. P stands for proton, N for neutron. Which two atoms are isotopes of each other? So what you want to do is pause the video and have a go at each question as they come up, and then play to watch the answer. So isotopes are atoms of the same element with the same number of protons, but a different number of neutrons. So we're looking for something with the same number of P, but a different number of N. You can see here, Q and R both have 10 protons, but a different number of neutrons. So they're isotopes. Cool. Let's get on to the next question. Which change takes place when an atom becomes a positive ion? Hopefully you know the definition of an ion. It's when an electron has been gained or lost. So here's an example of when an electron is lost. We've got sodium going to become a sodium ion. So our answer is B, when an electron is removed. One method of producing carbon dioxide is to react calcium carbonate with dilute hydrochloric acid. So what we've got to think here is acid and carbonate, what do they make? Well, you should remember that an acid plus a carbonate, excuse the caps lock, makes salt water and carbon dioxide. So straight off, we want to see, are we making salt water and carbon dioxide? We can see the top one's making hydrochloric acid. That's wrong. This bottom one's making hydrogen gas. C is wrong. It's making hydrogen gas. The top one's making hydrochloric acid. That's wrong. We'll look at B. B is the correct answer. It's making calcium chloride, and they've got the formula of calcium chloride right, whereas the calcium chloride in D is the wrong formula. Calcium is a group 2 metal, so we'll join with two group 7 ions, like chloride ions. Okay, what changes when an ion is made from an atom? So when you make an ion for an atom, what is it that you're changing? Well, it's the loss or gain of electrons. So when you're making an ion, here's an example of making a magnesium ion. You take away 2 electrons. And there's a little equation to show that. So it's the number of electrons that changes. Right, question 5. Strontium is a metal that forms an ionic chloride, SrCl2. Sulfur is a non-metal that forms a covalent chloride, SCl2. Which compound is likely to have the higher melting point, which is more soluble in water? Well, sulfur and chlorine are both non-metals, so they're going to be covalent. And strontium's a metal, chlorine's a non-metal, that's ionic. Ionic and covalent both have high melting points if they're giant structures. However, in this situation, it's only the strontium chloride that's a giant structure. So the answer has to be A or B because that has a high melting point. And then more soluble in water, again, that's the strontium chloride. Ionic substances tend to be soluble in water, or more soluble than covalent substances, and it's because they're made of charged ions, or oppositely charged ions. Okay, here we go. Question 6, guys. The diagram shows a model of an organic compound. You can see here the black circle is carbon, the white circle is hydrogen. We've got a key here. What's the name of this compound? It's got 2 carbons and 6 hydrogens. So we've got possible answers: ethane, ethanoic acid, ethanol, and ethene. Well, if we draw out the formula C2H6, that's ethane. That follows the general formula CnH2n plus 2. You should know that that is for alkanes. So this is an alkane, and the only answer ending ane, alkane, is ethane. Eth means 2. So, but all of the answers contain 2 carbons. Okay, let's go. Question 7. An organic compound contains 38.4% carbon, 4.8% hydrogen, and 56.8% chlorine by mass. What is the empirical formula of the compound? So to work out the empirical formula, sometimes you're given percentage by mass like this, or sometimes you're actually given grams. Whatever it is, you're going to divide it by the AR of the element. So 38.4 over 12, because 12 is the AR of carbon, 4.8 over 1, because 1 is the AR of hydrogen, and 56.8 over 35.5, because 35.5 is the AR of chlorine. So whack them in. So essentially you're working out moles. You can think of those percentages as grams, and you're working out the moles of each. So we're going to work out that's going to be 3.2 moles of carbon, 4.8 moles of hydrogen, and we're going to end up with 1.6 moles of chlorine. So let's make sure we identify them. And then we want to divide all by the smallest. So you want to simplify this into a ratio. So divide all by the smallest, which is 1.6, and we're going to get carbon, hydrogen, and chlorine. And we're going to find that there are 2 carbons for every 3 hydrogens for every 1 chlorine. So the simplest formula or empirical formula is going to be C2H3Cl. And the answer is A. Let's go on to question 8. Which of the following contains the greatest number of hydrogen atoms? Okay, so we've got moles of everything and we've got the formulas. So we can just times the moles by the number of atoms in the formula. So we can just do 2 times 2 is 4. 1.5 times 3, that's 4.5. 1 times 2 is 2, and 0.5 times 4 is 2. So it's going to be 1.5 moles of ammonia will have the largest number of hydrogen atoms. 9. Which of the following formula for compounds of germanium is unlikely to be correct? Given the position of germanium in the periodic table, we're looking at unlikely to be correct. So what position is germanium? You'll have a periodic table, look it up. It's in group 4, just like carbon. So if we're looking at which one is unlikely to be correct, well, germanium's in group 4. So if we look at A first of all, we say germanium should form, for purposes of writing formula, germanium will form a 4+ ion or a +4 ion. Fluoride is a -1 ion because it's in group 7. So they should form in the ratio of GeF4, not GeF3. So that is incorrect, which tells us that our answer is A. Now we could move on normally, but I'll go through the others. Germanium is +4. Sulfur is in group 6, so will be -2. As there's 2 -2s to go with the +4, they cancel out. That's the correct formula. Germanium oxide, +4. Each oxygen's -2, so GeO2 would be correct. And germanium hydride, you've got germanium +4. Now, hydrogen can be -1 or +1, so that would be correct. Let's move on. Which of the following does not have exactly 10 electrons? Well, fluorine has 9 electrons. A fluoride ion would have 10 electrons because it would have an extra electron. Let's look at sodium down here. Answer D, because it's a nice and easy one to look at. Now, a sodium atom would have 11 electrons, but when it becomes an ion, it would have 10. So that's got exactly 10. Now, methane would have, carbon has 6 electrons. Why have I written 12? Idiot. Sorry. Carbon has 6 electrons and hydrogen has 1 electron each. So that's a total of 10 for that one. Nitrogen has 7 electrons each, so that's 14. So it's nitrogen that doesn't have 10 electrons. A molecule of nitrogen. Each has 7. Nearly made a mess of that. Question 11. Which pair of atoms contain the same number of neutrons? What we want to do here, to find out the number of neutrons in an atom, do the mass number, take away the atomic number. So for A, we want to go cobalt 59 minus 27. That's going to give us 32. We want to go 59 minus 28. That's going to give us 31. So A is not the correct answer. They don't have the same neutrons. Look at B. 64 minus 25. 29 is 39. And 65 minus 29 is 36. They don't have the same neutrons. Look at C. 64 minus 29, that's 35. And 65 minus 30 is 35. So C is correct. Both of those atoms have the same number of neutrons. We can see D here. We've got 36 on that one and 65 minus 30, 35 on that one. So yeah, the answer is C. Okay, let's move on. Question 12. Remember to pause the video and have a go. Which statement describes the bonding in sodium chloride? Well, sodium's a metal, chlorine's a non-metal. You should know that that means it's ionic. 2 non-metals, covalent, metal and non-metal, ionic. So we're looking for the definition of an ionic compound, and it's a strong force of attraction or ionic bond, a strong force of attraction between oppositely charged ions. The other ones give a mixture of covalent or not relevant definitions at all. Question 13. A compound has the formula XO2. It has a relative mass of 64. What is X? Well, we know that oxygen is 16, each oxygen atom, and there's two oxygens. So the total of oxygen is 32. So what must X be? 64 minus 16 times 2, X is 32. And if you look up in the periodic table, you'll find that that is sulfur, has an atomic mass of 32. Okay, question 14. Metals W, X, and Y and Z are reacted with dilute hydrochloric acid, just shrinking it down to fit the question in. The oxides of metals W, X, Y, and Z are heated with carbon. The results are shown. So we've got two reactions done to work out the reactivity. One with acid, which is really easy to see. You can see the most reactive one is violent fizzing. And then we've got W and X, they both just fizz. So we need to be able to tell the difference between W and X because they both fizz with the acid. Well, when they're reacted with carbon, there's no reaction with W, but with X, a metal is produced. And that's a displacement reaction below. So actually, most reactive to least reactive, we are looking at Y is the most reactive, followed by either X or W. In this case, it's going to be W. And then we got X. And then we got, in last place, we've got Z, which has no reaction with acid and is displaced. So, yeah, there we go. 15. Aqueous 3 sulfate and aqueous sodium hydroxide react to give a precipitate of iron 3 hydroxide and a solution of sodium sulfate. What is the balanced equation for this reaction? Often with these reactions, they'll write the formulas wrong. So let's just check the formulas. Iron sulfate is Fe2SO43. Yes, they've done the formulas right for all of those. Sodium hydroxide is NaOH, and they've done the formula right for all of those. So we're not going to get any cheat mode here. FeOH3, yep, they put that for the iron 3 hydroxide. And then sodium sulfate is Na2SO4, and they've got that right for all of them. So it's really the balancing that you have actually got to check the balancing here. Sometimes they mess the compounds up. Well, look, we got 3 sulfates, so let's just make sure we got 3 sulfates. There aren't 3 sulfates on the right. Now, there's 3 on the left for B, and there's 3 on the right for B. That's potentially right. Let's look at C. 3 on the right, left. How many on the right? 3. Right. For D, there are 3 on the left and 6 sulfates on the right. So that's definitely wrong. And then for B, we can see the ions are not balanced. So it looks like C is the correct answer because there are 2 Fe's on both sides as well. Okay, 16. What's the relative formula mass or the MR of HNO3? Let's remember that H is 1, N is 14, and O is 16 in terms of their AR. So I need to do 1 plus 14 plus 16 times 3. So that's 1 plus 14 is 15 plus 48 is 63. Okay, 17. Which is the correct structure? Okay, so to work this out, you need to know when you're dealing with organic compounds like this, carbon's in group 4. It can only have 4 bonds around it. So try and spot one of these, A, B, C, or D, where the carbon atom has more than 4 bonds. And over here at C, have a look there. There's a double bond and 3 other bonds. That's 5 bonds. That's an impossibility. Carbon cannot have 5 bonds. And you can see that's happened twice there. So that is an incorrect structure. C could not form. Okay, 18. Caffeine is a stimulant found in coffee. Which formula represents caffeine? Right, we need to do a bit of adding up here. So first of all, let's see, does it have 7 or 8 carbons? The answer A has 7 carbons, B, C, and D, 8. So this has got 8 carbons when you count them up. So A is definitely wrong. Now, does it have 10 hydrogen? That will mean it's B or C. If it has 11, it's D. It does have 10 hydrogen, so we can get rid of D. Okay, now let's count up how many nitrogens are there. So B has 3 nitrogen and C has 4. I can see there are 4 nitrogens here. So the answer is C, not B. The correct answer is C, and all of those have 2 oxygens. So yeah, there we go. Okay, question 19. Which compound is made from elements which are all in the same period? What do we mean by period? A period is a row in the periodic table of elements. So you just need to whip out your periodic table and look if they're in the same period. So you've got like aluminium, sulfur, and oxygen. Well, sulfur is below oxygen in its group, so they're not the same period, sulfur and oxygen. Hydrogen is above carbon or oxygen, so B is wrong as well. Now you'll find that lithium, nitrogen, and oxygen, they are all in the same period. Okay, period 3 of the periodic table is shown. What increases as we go from left to right? So think about this: sodium, magnesium, aluminium, silicon, phosphorus. Well, they're all solids and sulfur. And then we go chlorine's a gas, argon's a gas. So that will help us out. Chlorine and argon are gases. So we know the melting point can't be increasing because it must be going down because gases have a lower melting point than solids. We know the number of electron shells isn't changing because they're in period 3. They all have 3 shells of electrons. And then if we look at the density, what's more dense, a solid or a gas? Obviously, a solid is more dense. So we know the density isn't increasing. So the only thing that is increasing is the non-metallic character. They become more non-metal as you go across. Question 21. Table shows the structure of 4 atoms, W, X, Y, and Z, with the electronic structure 281, 284, 287, and 288. 281, we're looking at sodium. It's a metal. It's from group 1. Now, just bear in mind, covalent compounds are non-metal only. So the question is, which 2 atoms form a covalent compound? So nothing with W, A and B should not be able to form a covalent compound because they contain a metal. The most common mistake was probably to say W and Y is the correct answer because they pair up perfectly, but that would be ionic. Noble gases shouldn't really form compounds, so anything with Z in shouldn't be a compound. So anything with Z and W shouldn't be able to join. So it's going to be like X, which could join with Y, and it's like a group 4 element and a group 7 element. So you get like X, Y4 would probably be the formula. And so X and Y can form a covalent compound. Right, 22. The structure of a monomer is shown. Monomers, remember, can be squished together under pressure to form polymers. And this is a form of addition polymerization, and it's quite easy. You can see that the polymer it would make would be B. All you do when making a polymer is get rid of the double bond if it's an addition polymer and draw 2 lines on either side going out the brackets. 2 atoms of magnesium react with 1 molecule of oxygen. What's the correct formula? Well, MgO. Magnesium's 2 plus, oxygen's 2 minus. The correct formula of magnesium oxide is MgO. Lovely jubbly. In the following diagrams, X and Y are atoms of different elements. Which diagram correctly shows the arrangement of outer electrons in the molecule of methane? Okay, so methane has the formula CH4, so we're looking at 5 atoms, so A definitely can't be right. And you should know that hydrogen only has 1 electron, so those Y's represent the hydrogen with its 1 electron, and the carbon is represented by the X in the middle. 25. Which statements comparing the properties of electrons, neutrons, and protons are correct? Well, we know that neutrons and protons are heavier than electrons. That's true, so A or B could be correct, but only electrons and neutrons are charged? No, that's not true. Electrons and protons are charged, so B is the correct answer. Right, 26. The equation for the complete combustion of ethane is 2C2H6 plus 7O2 goes to 4CO2 and 6H2O. What volume of oxygen measured at room temperature and pressure is needed to completely burn 0.1 moles of ethanol, of ethane? Bearing in mind that 1 mole of any gas is 24 dm in volume, well, we can see there's a ratio of 2 to 7 from ethane to the amount of oxygen needed. The ratio is 2 to 7. We have 0.1 of ethane, so we need to multiply that by a ratio of 7 over 2 to find out how many moles of oxygen we'd need. Obviously, you need a lot more oxygen, and you'll find that if you multiply that by 0.35 or 7 over 2, you find that we need 0.35 moles of oxygen. So what volume of oxygen is that? Well, it's 0.35 times 24, and that is going to be 8.4. That is the volume of oxygen we'd need. Okay, the hydroxide ion, OH minus, has a total of 9 protons. How many neutrons and electrons are there in the ion? Well, oxygen has a mass number of 16 and an atomic number of 8, so it has 8 protons. Hydrogen is just made up of 1 proton. It's basically a proton and an electron. So there are a total of 9 protons, 10 protons. 9 9 protons, 10 electrons, 8 electrons from oxygen, 1 electron from hydrogen, and 1 electron from the minus with the OH minus. So there's 10 electrons and 8 neutrons, 8 in oxygen, none in hydrogen, and none on the bonus electron. Right, 28. Calcium reacts with dilute nitric acid to form calcium nitrate and hydrogen. What's the correct balanced equation for this? So again, just check the formulas and you'll get most of these right. So we can see here that calcium nitrate in B, that's the incorrect formula. Calcium's a 2 plus ion, so it needs to join with 2 NO3 minuses, so B is incorrect. Look at the formula of the nitric acid in C. That's not the correct formula for nitric acid. The correct formula is HNO3, so C is incorrect. And now let's look at D. Again, they've made the calcium nitrate mistake. They've used CaNO3. It should be CaNO3 which is in the top one. So A is the correct answer. And you could really just check that by checking that all the formulas are correct. 29. Ions with the same electronic configuration, oh my God, I couldn't speak, are said to be isoelectronic. Which of the following compounds is made up of isoelectronic ions? Basically, do they have the same electronic configuration? Well, oxygen, the oxide ion is 2,8. Because oxygen's 2,6, it gains 2 electrons to become 2,8. Calcium 2 plus, well, it's 2,8,8,2 when it's calcium, drops 2 electrons, becomes 2,8,8. So they're not isoelectric. And then you can see here, oh, we don't have to do bromine. It's got loads of electrons, so it's definitely not those two. What about sodium and oxygen? Well, a sodium ion is 2,8 and an oxide ion is 2,8. So those, letter C, is the correct answer. They both have the same electronic configuration. Last question. If X represents the element of atomic number 9 and Y has an atomic number of 20, the compound formed between these two elements is A, B, C, or D. Well, that's going to be calcium. And if you look in your periodic table, the element with an atomic number of 9 is fluorine. So we're looking at calcium fluoride. Calcium's a 2 plus ion. Fluoride is a -1 ion. So they're going to come together in a ratio of CaF2, calcium fluoride. And that means it's going to be YX2. Now, is it covalent or is it ionic? Well, calcium's a metal, fluorine or fluoride ions are non-metal. So this is ionic and the formula is YX2. And that's your lot. So don't forget to share, like, subscribe, leave a comment. Let's get to the marks.
You're still here? It's over.